Good evening, everyone. So today, as you can see the topic, I will be talking about NumPy in pandas. So before starting, let's give you a brief introduction of what NumPy is. Well, NumPy is a Python library. Okay, so we have lists that serve the purpose of arrays, but they are slow to process. NumPy aims to provide an array object that is up to 50x faster than traditional Python lists. Okay. Arrays are very frequently used in data science where speed and resources are very important. So basically, NumPy is used in a branch called data science. It's where we study how to store, use, and analyze data for deriving information about it. Okay. So, this is a brief introduction. Let's first show you how NumPy configuration is done and everything. And later on, I will be discussing about more topics. So this is my VS Code. Okay. Let's create one part 1 dot Python file. Okay. So first we need to, since I said that NumPy is a library in Python, so we need to uh, import the NumPy library first. So I will be writing import NumPy. Let's give an alias name np. Okay. So this is how we import a NumPy library. So let's show you how to create one-dimensional, two-dimensional, or three-dimensional arrays. Let's talk about one-dimensional array, how we create. So 1D array. So the method to write one-dimensional array is np dot. See, there are so many methods, functions are there in under NumPy that we can do here. So many functions are there we can do for mathematical calculations as well. That is why NumPy is so important. Okay, which is not possible in list. There are certain functions, but the complicated mathematical calculations, we cannot do it in list, but that can be easily performed by NumPy. So to create a one-dimensional array, the syntax is np dot array, and then there's a function, and then if I write, let's say, 1 to 34, okay, and now if I print it, ARR1, let's see, if I run it, yes. So you can see this is a one-dimensional array, right? It has come in the form of 1D array. Now, how you will check that whether it's a one-dimensional array or not? Well, therefore, there is another function. If I call ARR1, which is the name of it, dot ndim. So this is a function, as you can see, which will tell you what is the dimension of ARR1. So if I rerun it again, so it will say, see 1. 1 means the dimension is 1. Similarly, I can create another 2D array as well. So to perform 2D array, let's give it the name ARR2, np dot array. Well, now to create a 2D array, you have to understand that what is actually a 2D array. Well, 2D array is basically what we call matrix, right? So there will be row and there will be column, right? So in 1D array, there is no column and row. There is only one single element, right? So a list of elements that you can say. But in 2D array, there will be row and column as well, right? Uh, so to do that, we need to write. So if I perform in this fashion, okay, before talking you, let's just show you how the 2D matrix configuration is done. So as you can see, I have written a 2D matrix. which represent rows and columns. So let's say if this is if this is my row, so these are my rows. Okay, I write it with R, and these are my columns. This is one column, this is another column. Let's say C. So number of rows 2 and number of columns C. So this is what we call as 2D matrix. Okay. Now let's say this. Now just imagine how we will describe this part in an NumPy array, in array. Well, consider if this row is a list and this row is another list. Okay. And overall, so I right now I have two lists, right? This one and this one. So this two is forming a single plane. So this is this square structure basically. See, this is a plane. Suppose I've written it over here. Suppose I've written in a page 2, 4, 8, 5. The row and column is here, right? This is a plane. I say a plane. That what we call as plane, right? So this is one plane. Okay. So that whole plane will come under one list. So this is actually, as you can see, nested list is forming, right? This is one list, this is another list. The rows, each row represents single list. And when each row is performing a whole plane, that is also coming under a list, right? So this is how we represent 2D matrix in a NumPy array. So let's write this over here. So this is right now, this is my 2D array. Okay, let's clear the terminal. Okay, so here it is. Here, let's consider, let's write this value only 2, 4, and 8, 5. Let's write this list first and then the second list. Okay, so this is one list. So 2, comma 4, and another will be, I think it's 8 and 5. Yes, 8 and 5. But if I write this, this will give an error. This will give an error. See if I write this, okay. This field element must be 2 or 3 tuples. So I have to include this part inside another list. So this whole thing forms a plane. So let's write it inside the complete list. Now, if I write this, okay. So as you can see, 2, 4, and 8, 5, right? So similar structure that I have written over here in the form of row and column. So if you can see, if you can see minutely, this is actually a nested list, right? List under list, a list under list. Basically, if I write like this way, this fashion, 2, 4, and then comma, 8, 5, right? So this is actually a nested list. So as you can see here, had I been used a list over here in instead of NumPy array, so then I had to write in this fashion. So there will be so many lines would have been there, so many codes that I had to write over here to build this particular array, right? But if I'm using NumPy over here, so within one line I can create a two-dimensional array, right? Very good. Acha. How to check the dimension here? If I do ndim, if I run it, 2. Okay. So similarly, we can also create three-dimension array, four-dimension array as well, right? So before going to the three-dimension array or four-dimension array, okay, first show you what is three-dimensional, how three-dimensional array are done. Then I'll go back. So when we are writing a three-dimensional array, what is happening in spite of row and column, there is another part called height, right? That we say in a three-dimensional array. There is x-axis, there is y-axis, and there is another called z, right? That when forms a whole three-dimensional array, a 3D structure. So how we how we define a three-dimensional array. Please consider three-dimensional array is a complete 3D. So it's at that point there will be no one plane will be there, right? If I perform two planes, if I keep two planes simultaneously, then it will become a whole box like structure. That is a 3D part, right? So can't I do this one that there will be one plane, there will be another plane as well. That will be forming a cube-like structure, which is a 3D array. Let's just write it. np dot np dot so array. Now a whole plane, inside a whole plane, there will be, since as you understood that one plane consists of rows, so number of rows and then comes a number of columns. So this is a whole plane. Inside the plane, there will be another first plane will be there. Inside that plane, I will write, let's say 1, comma 2, 3, comma 4. This is one plane. Another plane will be, let's say 5, comma 10, 11, comma 12. Now, if I print this, okay, if I rerun it once again. Yes, as you can see, this is my three-dimensional array. 1, 2, 3, 4, 5, 10, 11, 12. So this is a plane, this is another plane. Both of them are forming a cube or a 3D structure. Now, if I want to confirm it, I can do it using n, sorry, ending, run it, 3. So this confirms that this is a three-dimensional array. So basically what is forming, if I want to draw this is in the form of a plane, if I open my paint, so it will basically form like this structure. This is one plane. So over here, like if I write inside this, what is it? 1, 2, 3, 4. So this is 1, and then this is 2, this 3, this 4. This is a plane, and another plane will be at the back side. So I draw like in this fashion. Okay, if I draw in this fashion, maybe not be good. Okay, if I draw in this fashion. So over here, if I draw this, so what are the values are there? It is 5, 10, 11, 12. It is 5, 10, and then okay. Next value will be 11. I should have written in different color, then it would be much better. Okay, no problem. So as you can understand, this is one plane and this is another plane. So this is kind of forming a separate box. If I join this, if I join the whole structure, so this forming a box or a 3D part, right? This is actually a 3D structure where 1, 2, 3, 4 are coming in single plane, another row is coming in another plane. So this is a list. Inside the list, each row is each list. This is another list. Inside the list, there will be each row where representing each list. So nested lists are performing and overall is coming under a whole list. So nested list, right? Nested list. So this is how we can create a three-dimensional array. Now, okay, there is another way also to perform a three-dimensional array. We do not read to suppose this will take so many time to uh, perform this, right? 1, 2, 3, 4, 5, 10, 11, 12. So we have to, not only this, we have to write it so many times, the list and the list and the list. I can also write it in another way as well. So let's just comment out this line and write over 3 equals np dot array. And just if I write, so how many I need to write 1, 2, 3, 4, 5, 10. 1, 2, 3, 4. Sorry. 1, 2, 3, 4. And then 5, 10, 11, 11, 12. 1, 2, 3, 11. This, and then here I will be writing ND min equals to 3. This will also form a 3D array. Okay. This is also a 3D array actually, but the structure is it's slightly in different form, but this is actually a 3D array as well. You can also write a 3D array in this. No, I'm sorry. It was the wrong information. Basically, what is happening over here is this is a single dimension array, but I'm converting into a three-dimensional array. Okay, I can convert single dimension array or a two-dimensional, three-dimensional array. But I cannot convert a three-dimensional array into vice versa, is not possible. So what I'm doing is that this is a single dimension array, but I'm converting single dimension array into three-dimension array. So what's happening over here is there is one row, right? There is one row. Number of column is 1, 2, 3, 4, 5, 6, 7, 8. Number of column, number of elements is 8 over here. So how the thing is written, the fashion is, so basically, as you can see, there are three planes, uh, or three planes are there, right? Three planes. And so you can also say like that, keep uh, two planes are there. So basically, what it describes is that three planes are there. Okay, three planes where eight number of elements are there under which there is one row, and this is coming under three planes. So I can convert a 1D array into 2D array. I can also convert it into 4D array as well. See, this is my 4D array. As you can see, it's showing 4. And now you can see so many nested lists are formed. So what it's showing is that four planes are there. These numbers are standing on four planes. Okay. Uh, this is what I wanted to show. Okay. Now the next part is, okay. So basically what is happening over here, let's explain you in brief, is that this means the first uh, I can define you that what actually you will not understand from this area, but there is another function that will make you understand. There is a function called shape. So if I do like this, print arr3 dot shape, arr3 dot shape, and now if I run it, okay, this for me an error. Okay, this is, sorry for that. Um, okay, now ready. Yes. So what it's saying is that this is actually describing the overall shape of this particular array. Right? Over here I have mentioned dimension is 4, but this is actually a single list, a row, a single row, or a single list which has no plane. Right? So what is this will actually tell me that this is a cube, or we can say a plane. Second one is actually representing a row. So this is one row, and this part. So this is no, sorry, this is a cube. This is a row, plane. This is a plane, and this is a row, and this is number of elements are there. Okay, this is what number of elements are there. So number of elements is 8. Overall, the dimension is 4. Overall, the dimension is 4. Number of elements is 8. Number of row is 1. Number of plane is also 1. So there is a one plane. There is no three planes. How there will be three planes if element number of elements is 8 over here? The number of elements is 8. Number of row is 1. Number of plane is 1. And this is coming in the whole cube, which is 1. So this is how we can convert a single dimensional array into multi-dimensional array, but vice versa is not possible. Okay, this is up to this part. Next, I will be talking about, let's just comment out all this line. This is about how we can perform a array. Now I will show you some of the methods, functions that we can implement inside the NumPy. There are certain attributes are there. So as I shown here, this shape is one of the attributes. We want to know that what is actually uh, the shape of this particular array. So it will show you the whole structure, or you can say the whole dimension of it. Okay. If I want to know what is the data type of the array, let's take the example of this one only. If I want to know the data type of this particular array, so there is a function called AR1 dot ARR1 data. This is not a function, these are the attributes. Okay, I was mistaken. Shape, D type, these are not functions, these are called attributes. Okay, attributes which is falling under NumPy. If I print this, it will show you the size in 64. Since integer is holding, since 1 byte is equals to 8 bits. So this is actually, since integer has 8 byte, so overall it will be 1 byte equals to 8 bits. So integer contains either 4 bytes or 8 bytes. I think for long it is 8 bytes, and for smaller version integer it is 4 bytes, but typically we consider it as 8. So 8 into 8 will be 64 bits. So this is actually showing me 64 bits. If I do in points, then it will show me the float. Since one of the element is in float, then it is showing float 64. So this will show the data type of it. Okay. Next attribute, okay, shape was another one. Okay, let's show the shape as well. ARR1 dot shape. Uncomment this part, comment out. Okay, so this is 4 and comma. As you can see, this is showing in the form of tuple. Right? In tuple, we cannot write a single value enclosed in a bracket. If it's a tuple, we need to write it followed by comma. So it's a tuple, and what it's showing, what is 4 over here? 4 is the number of elements. Okay. 4 is the number of elements. Now, next item will be ndim, which I shown you before only. This I already shown. This is also falling under the attributes. Okay, these are not a dimension a function. These are attributes. Ndim, that will show the dimension of it, which is 1. Another is, okay, another there is item size. This is item size. Item size. You run it. Now it will show the, so item size means actually it will show in a form of the data type. So what integer byte is 8, so that's why it's showing 8. If it is, let's say, 6 float type, this is also 8. Okay. Okay. So these are all certain attributes falling under NumPy. Then there is also certain functions. Okay. So many functions are there. One of I will be showing you some functions which is falling under NumPy. One of a kind is 0. So there is a function called 0. So what it does is, if I want to create an empty list, np dot zeros, and if I write 3 over here, let's see what it prints. Well, certain list will form, as you can see. This is a float type. You can see 0 points. This is actually a float type value. A single dimensional list containing 3 zeros are formed. If I want to know the dimension of it, then if I run it, it will tell me it's a 1. If I want to know the data type of it, it will tell me it's a float. So it is actually creating a float type integer, float type values, zeros. Now I can also create a 2D matrix as well. How will I do it? If I write over here 2, 2, comma 2, comma 3. So what is it? This is actually number of planes. So 2 planes, number of rows, 2 rows. So each plane will have 2 rows and 3 columns. This is what is showing. So what I will get the value, 2 plane will be there, just like this 2 plane will be there. And in each plane, 2 rows will be there filled with zeros. And how many number of zeros will there? 3 zeros will be there. 1, 2, 3. Since I have written 3 columns. So let's see, let's erase it and rerun it. That's the problem. Okay. See, this is a problem. It will take one uh, argument only. So I have to enclose it inside a list or a tuple. Yes. So this is my value. As I said, 2 planes will be there. This is one plane, this is another plane. Each plane will have 2 rows and each row will have 3 columns contained filled with zeros. Okay. Acha. There is another one. There is another one. In spite of 0, it is ones. So if I want to print, so give it, uh, let's say O. This one for, need one for 0. Okay, this is for O, which will say 1. So let's comment out this one. ARR. Commented out, so not to worry. Okay, 1. Now if I print this, so instead of 0, it will form 1. See, 1 followed by dot. So these are all float type values are forming. Okay. Okay. There is another thing as well. Let's give it E. So what it does, it will create same like 0 and 1 date, but in spite of 0 and 1, it will print any random value, or we can say any garbage value. So let's print ARR of E. If I rerun it, okay, sorry, written spelling is wrong. If I rerun it, so as you can see, so many values, it's a garbage value has been generated. Another function is, again, the same thing, but it will print the value in the form of diagonal fashion. Okay, I haven't printed, that's why it's deep. Just showing you some of the, it's a very less functions that I'm showing. There are so many are there. Okay. So as you can see, the value will be formed diagonally. So 2, 2, 3. same 3D, this whole array will form, but the value will be printed diagonally. Okay, so these are, I tried to show you some of the functions and attributes coming under NumPy. As you can see, this is a very minute thing. There are so many mathematical calculation that is performed under NumPy, which is not possible in list. And there is another difference is that this is a NumPy array, and there is a difference between NumPy array and this, which is list contains heterogeneous type values, right? We can so a single list consists of integer, character, float type values. Even it also contains integer nested list as well. But in case of array, it only contains homogeneous value. If I want to, so the array will contain only similar kind of data type. If I want to create a array of integer, it will contain only integer type value. It will not contain the mixed or heterogeneous type of value. And there are other important points as well, but these are some of the one of the kind. Okay. Okay, I hope you enjoyed this had because this has become a bit longer video, but I hope you understood. In the upcoming videos, I will be also explaining some other functions as well. Okay, so thank you and bye bye.